battery management system. In this, how we are going to apply it for a electrical vehicle. The battery management system is very, very important, as this battery management system is a core of your electrical vehicle. Is very, very important part, such that to maintain your battery is the core of your electrical vehicle. Maintaining it is very, very important, as you want to prolong the duration of your battery vehicle. Okay, everything is important. Battery is very much important, because in an electrical vehicle, the costlier part is your battery. So maintaining it and spending money on that is important for us. Can you clearly?
Yes, madam, you are audible.
Thank you. Yeah. Going starting, see that we want to compare why we are going for a different type of battery. See, at the starting, we are using a lead acid battery. In a lead acid battery, what is where it is applied is, it is applied in a UPS, electrical vehicle, as well as car batteries. Okay, these are the three portions where we have applied a lead acid battery. What is a very, very difficult part in your lead acid battery is, it is very heavy. Have shown the positive as well as negativity of your all the type of batteries. In a lead acid battery, it is very, very simple. Only plates you have. You can pour the electrolyte within it, and you can extract power from it easily. The construction is also very simple, and it is very cheaper also. As it is a well-known proven technology, it is easier and simple. Cost is very low in case of a lead acid battery. Okay. And coming for your disadvantage of a lead acid battery, see that it has low specific energy power energy density. Okay. The energy weight ratio is very, very poor. Okay. That's why the energy density is very low. So that only it is not used. If you are increasing cost, Vijay, can you mute? Thank you. And see that it has a very low energy density. If you're going for a heavy power increasing watt hour, what happens is the weight of the battery keeps on. For example, if you are using a vehicle, okay, mostly the small vehicle needs 80 kgs of lead acid battery. That's the problem there in your lead acid battery, and it is also slow charging. You have seen that in your lead acid battery, if your vehicle battery is lower, will be giving charge for 12 hours, even for starting and fast parking. Will be using lead acid battery in the cars. See, if your batteries are completely discharged, how much time it will take to charge again. It's very, very difficult. Also, the weight is the major problem in the lead acid battery, and the limited life cycle is also a problem in that. After that, they evolved is a nickel cadmium battery. Nickel cadmium battery has a long usage, but what happens is it is a fast charging, and then it has good life cycle also, and the temperature performance very good in your nickel cadmium battery, and it is economically also very good, and it is storable, and it is transportable. But I'm again coming for your energy specification, it is very low, and if it is memory effect, and it creates toxics. That's the major problem. We are not gone for nickel cadmium. It is a toxic to environment. It's very, very is a greater problem for us, and it has high self discharge is very high. Okay, if you are not using also, it is discharging faster. It keeps on discharging. Coming to evolving from the lead nickel cadmium, what happens is nickel metal has evolved. Nickel metal hybrid has been evolved. In that case, it is better than the nickel cadmium by 30 to 40%. Okay, yeah, and it is also has the advantage like simple storage and transport from your nickel cadmium, and it does not produce any toxicity. Okay, that is a major advantage of that. And what is the problem with this is high discharge. Even though we have removed the toxicity of nickel cadmium, when coming to a nickel metal hybrid, it is evolved, not stopped the emission of toxic materials. But what happens is it could not stop the high self discharge. That's a problem with both nickel cadmium as well as nickel metal hybrid. Okay, so what we have, we are searching for all these things, and uh, at last come for a lithium ion battery. What is a great advantage in this case is it is having high capacity and long range. Okay, this high capacity is very, very important. Even though if you have a vehicle capacity of a normal vehicle which is running at a speed of 60 kilometers per hour, it can carry a small battery of just having small as minimum as 1 kgs. Okay, that is compare that. Lead acid has to carry 80 kgs, while as same capacity with the lithium ion can carry only 1 kgs of weight. It's a greater transition. That's why we are always going for lithium ion. Also, relatively it is low self discharge and it is low maintenance also. There is no memory also needed, and now and all if you are using artificial intelligence, the memory is needed. Okay, so that is needed. Then if you are not using any controllers, then no memory is used there, and it is subject to aging. That is a problem with that, and it is very, very important to protect your lithium ion battery. Requires protection circuit. Why it is very, very important is if you crush your lithium ion battery, it will burst. Simple as it is. It is having a time bomb in your vehicle. Simple as this. If your lithium ion is crushed, okay, it is damaged. It can burst as it is a time bomb. Okay, that's the major problem and difficulty. So that they are giving more protection. Protection circuit is very, very important in case of lithium ion in anything. Okay, and it is subject to aging, the transport reliability, and it is shipping is high, which is high volume. You can do it. And coming to your next slide, so that you can see the types of lithium batteries we have. Okay, these are the types of lithium ion families which we are using frequently. Okay, we have evolved from lithium ion to all these types. These are all chemical names which you can see. Lithium, other than lithium ion, what are the evaluation you have? In this case, you have a diagram of how the energy density is for your lithium ion. See that lead acid is very, very low. Nickel cadmium is more than that. And nickel metal hybrid is more than that. And you have lithium ion, which is having high energy density as well as gravimetric energy density also, that is kg. What is the watt per kg you can consume is very, very important. And for lithium polymers, which is listed in the site, will be in the central part. Okay, that is very a pronoun form of lithium batteries. Okay, that is in a research point of view. These types are very, very important so that you can still optimize the lithium ion batteries. And this is the lithium ion manufacturing in the companies, how you can see the lithium ion, how they are placing it in under the seats. You have a motor, you have an inverter, and then you have a lithium ion battery. See, you can shape it in any structure. In this case, it is this company have shaped it in a a different structure and under the seats. See, you can also see a structure with Chevrolet. See how Chevrolet is designed and Mitsubishi has designed. You can see the difference. It depends upon the design of the vehicle itself. You can modify it in any way. You can modify it in a square shape, a longer shape, or whatever shape you will be like. Okay, so you can shape it in this way also, and you have more options with your lithium-ion batteries. Okay, that's the advantage of your lithium-ion battery. Any shape you prefer, you can merge it with your vehicle. Whatever case it is, it can be a square, it can be a circular shape, whatever shape. As why this case is that the packing of your lithium battery is very flexible. You can pack it in any way. See now, going for a packing of your lithium ion. Participants, is it clear? Can you hear my voice clearly?
Yes, ma'am, you are audible.
Yeah, thank you. Yeah, you can see your small lithium ion battery, how it will. You can see two batteries connected in series at the first and parallel connected. Okay, you can see a series battery connected in, and then parallel batteries connected. This is the package. You can see if this battery is 3.6 volt. Okay, when you connect in parallel, you will have a 3.6 volt. When you connect in series, you can see it is going to a 7.2 volt. So your voltage has been added. When you want to increase in your ampere, okay, ampere hour, we want to increase, we will connect in parallel ways so that the ampere hour of your batteries will increase. When you connect in series, what happens? The voltage of your battery will increase. Okay, it is very simple to design a lithium ion battery package because if you are connecting a small batteries, okay, small batteries together to form a big battery. Whatever size you want, you connect hundreds of battery in a single shot to get a required value of your battery. That is enough. So it is very simple to have whatever value of voltage you want. You can design it at any voltage you want. Okay, just only thing is how many cells you are connecting. You can see a packaging available in the lithium ion. You can see this is a series connection. You have a parallel connection. If you can add thousands of batteries like this. Okay, and this is the battery how we are packing. You can see in the core. Core is a battery which is placed in the cell holder. We have cell holder. We have a cell holder in which you will be packing your batteries. You will be packing all your batteries in the cell holder and then connecting them with like this. In the before slide, you will be connecting. After placing it in a cell holder only, you will be connecting like this. Okay, you'll be connecting parallelly, seriously. You'll be using a metal plates. Okay, usually it will be um, you will be using H-type plates or L-type plates to connect all your batteries. What is the condition you are going to connect? So you will be using that plates to connect. And after connect, you will be packing your cells in a cell holder. Okay, simple as it is. What is the size of the holder? You will be deciding. And then each cell holder can be separated and then connect it again. Okay, you want to connect it in a square way or you to connect it in a round way. Whatever it is, you can modify. Okay, after connecting all the in the cell holder, you will be connecting with the metal plates. After connecting it in a metal plates, what you'll do is you'll insulate all the whole lithium ion battery with the insulators. Okay. After insulating, you will be taking out the required connections from the lithium ion battery and connect it to a BMS. Okay, starting from the cell, why we are going for BMS? That's the after connecting to a BMS, we'll be packing it in definitely in a metal pack. Why we are going for a metal shield pack? is that it should not burst, right? We should not crush it. That's the important terminology. So always we'll be packing it with a metal pack. Okay, you can see every lithium-ion battery is packed in a metal pack. Okay, that is very essential. And you can see the connections. How if I want a 256 volt, have used as 80 cells. Approximately it is 3.5 or 8 volt into the 80. You will get 256. Okay, you can calculate as it is. It is all are connected in series, and each cell control should be in a slave, and then slave supply to a master. And this is very important, so that you can maintain each cell. Okay, why you are going for a BMS? What is the condition is each cell has to be monitored regularly. It is very important. If you are connecting a battery in a series case, 80 batteries in a series, if you one battery circuit you cannot access. Okay, that is the major problem with your lithium ion. If we are connecting in the series, if one is open, what happens? The whole circuit is open, so there is no supply. Okay, so for that, what we are going to do is we are managing every cell and a battery, and then monitoring each and every one, so that we can maintain reliability. Okay, and see, I have listed a theoretical part of what we have discussed in the last slides. You have lithium-ion batteries around 3.2 to 3.8 volt available in the market, as well as you can use one to two hundreds of cells connected in series, each identical, and then you can easily manufacture lithium-ion battery in your only thing you have to buy a cells. Each cell has to be borrowed. You are not manufacturing here in the country. We have to export from other countries. That's a problem. Researches are going on such that we will, if you manufacture a cell in our country, then lithium-ion battery will be very cheaper than our other countries. We will be self-reliable on all these lithium-ion batteries. That is the very important thing which we are planning. Our government is planning to make a lithium-ion cells. We are just manufacturing it for packing. We are exporting your cells and then just packing your lithium-ion. We are not manufacturing cells. For manufacturing cells, we are developing an R&D, and quickly we will be doing it, or India will be doing it. Okay, and these things we have already discussed. A problem with your lithium ion is you should not overcharge your lithium ion. Overcharging, what it will cause lithium ion batteries, it will cause overheating. Even explosion or flame will be happening if it is overcharged. This is a main thing we have to protect. We should not overcharge your lithium ion battery. And discharge case, what is if it is below the certain level, that is 5%, you cannot use your cells. Okay, certain has to be maintained. If your cells are discharged below this threshold, the capacity can be permanently reduced. Okay, you can it if it is below the threshold, you cannot recover it. Okay, that's you should throw a battery. That's all. So 5% threshold has to be maintained in the case of your lithium-ion batteries. And what is your need of your BMS? I've told that BMS battery charging. Why we need battery charging is BMS has to safeguard your device. Okay, device protection is very important, as it is very important in case of a lithium ion. It is very important to use a lithium ion. Okay, every protection circuit has to have an electronic switch with MOSFET, and this is the way they are doing it now. You can have IGBT, whatever cells you can have, and this BMS usually discharges with your MOSFET and charges with your MOSFET. That's where your controller circuit comes into place. And what is the mission of your BMS? It is first core of your mission is your safety. Okay, it protects the cell and battery from damage. That is the core of your BMS. And next mission is to performance and life, increase the performance and lifetime of your battery. And lastly, it has to maintain the battery in the state with which it fluctuates the fulfills the requirement. This is the last. Yeah, battery has to be prolonged. Yeah, safety is very, very important at the core. And then it has to increase the battery life, and it has to feed what is it is designed for. It has to apply for the required vision. And it's a virtual it's a vital device for an electrical vehicle because one second. Yeah, you have to manage the battery properly and then ensures the battery is safe to work. Okay, optimizing the performance of the battery is very, very important, and monitoring and control with this control unit of your battery. It will communicate with the other devices in your battery. EMS not only communicate with your cells, it also communicate with the other units of your vehicle. What is the function of your BMS? It is to protect, prolong the life, maintain the function of your battery. How to maintain the function of your battery? Battery function, you have to maintain the cell balance. Three terms are important when you come to battery maintenance. Okay, that is performance, battery balancing, and then you have to determine the SOC. You have already seen in the session before that Somasundaran sir have in the last session have taught you about the state of charge and state of discharge, all those things. That is state of health of your batteries. So I am not going to touch upon much on that as we have already communicated with that. And next part is communication to other units like vehicle control unit like that. Okay. And what is the function of your BMS? We have already seen what they are going to do. Okay. They will measure the values. What are the values they are going to measure is they are going to measure the voltage, the current, as well as temperature from the sensors. Okay, you have a sensor. All these things have three things has to be measured. With that measured value, we are going to calculate the state of charge as well as state of C state of health of your unit. Okay, state of power you can call it, or you can call it as state of health, or you can call it a state of discharge. Okay, all these things you have. All these things we can calculate with the formula, what we have measured from the voltage, temperature, as well as current, and diagnose what is a fault. You have major fault, you have minor fault, or you need to give a warning. Like that, you will be diagnosing and then control the problem. How to control the problem? You want to stop the vehicle, or you want to warn the owner such that it is showing indication of the C, you have a problem with this PMS, or it is overheated, stop the vehicle from running, then it will be cooled. So that is a function you can go for control. And you have already seen about the state of battery of the individual cells has to we can measure, and then it's very important to optimize it. Its state of charge. How you are charging a vehicle is very, very important. Uh, what is the state? You want to know the status of your vehicle, and then you can see the state of health. Okay, what is the health of your vehicle? Okay, the battery capacity to deliver it is very, very important. Normal capacity minus loss of capacity minus divided by nominal capacity will be a state of health of your vehicle. Okay, that is battery. Okay. And next case is here you have seen state of charge and state of health. And next thing is here cell balancing. In cell balancing, see multiple cells will be connected. What if your voltage of your cell is very low compared to other cells? Weaker cells will be overstressed, may cause during the charging case, and you can weaker cells may damage soon. All these things happens in case of your why we are going for cell balancing is very important, because there may be weaker part or a stronger part can charge quickly. All these things happens in your batteries. Coming to your balancing, you can understand with this diagram how variation occurs in your batteries cells. Cells are has to be equally charged. You can see in the second diagram, you can see all the cells are equally charged with 3.88. Why we are limiting it to 3.88? As it have a capacity of 4.2 is when your cells are charged up to 80%, it gives you higher efficiency or longer time. If it is charged to 100%, the lifetime of your battery will be low. Okay, so only we limit with your 80% of your charge. Already we have limited. It can be charged to 4.2, but we are limiting it to 3.881. Okay, now you can see overcharged cell. Again, the first diagram you can see undercharged cell also. The cell balancing, how we are going to implement it. It is unbalanced cell. You have a lower part A. Part A is a normal unbalanced cell, and then you have a balanced cell in the B part. How we are going to balance it is with a circuit like this. Each cell will be connected with a capacitor. Okay, each cell, how many cells it is, we can have any method of connecting a capacitor. This is the various part I have shown you. One is linear capacitor connection, another one is star shaped connection, or you can go for other mesh connection. Like that you can go for any type of capacitor connection. Only thing is you have to connect a cell capacitor which is equivalent to your voltage. Okay, C1, V1 will be equal to voltage C1, so that the cell, all the capacitor will have a same voltage, so that if capacitor will charge your batteries, capacitor will be charging your batteries and bring a balance to each cell. Each cell will be balanced each other. If voltage one cell is more charged, then what happens? Other capacitor will take that charge and give it to a cell which is less charged. Okay, so yeah, balancing will happen when you connect a capacitor. The switches will be controlled based on the requirement of a balance. How we are going to use your artificial intelligence in BMS is this control. This controller, how we are going to control all the switches will comes under your controller. So any controller can be connected with your artificial intelligence. Okay, and what are the parameter with BMS platform? Will be measuring voltage, current, and temperature. Your core, you have voltage, current, and temperature. You are going to see the state of charge, state of health, state of power, and you're going to control the cell balancing, and then you are going to protect it, and you are going to diagnose if you have any problem in this. And this is the way it is done. Okay, you have a sensor. You can see three lithium-ion batteries connected, and you can connect any number of lithium-ion battery. You have a sensor here for temperature sensor, and then your current, and then cell voltages are measured with the circuit. After temperature measurement, temperature management will be there. Heater or cooler will be given, so that if it is very cold also, you have a problem. So heater is provided. If it is very hot also, you'll be using a cooler with coming from the sensor. And you have a battery management system in which you have voltage sensor, cell balancing, state of balancing also present here. And you will have a leakage management also. Have charging management and discharging management also will be present. And then you have energy. Okay, not only all these things combined together to form a BMS. Not only one thing, you have to have a leakage management, charging management, battery management, energy management, distribution management also. How we are going to discharge it, every control. So BMS has a major part in cell maintenance, not battery maintenance. Battery is the whole thing. Each cell has been maintained individually. That is the very important part of it. And you can see how your temperature management has been done. In cell failure, how we are getting a sequences of what is the problem you have. If you have cathode breakdown and you have electrolyte breakdown like that, you have overheating, over current is present, over voltage is present, and low voltage is present, low temperature is present. What is the consequence of okay? What is the consequence of it? And when what is the action you are going to take, and what is the result you have? All these things has been listed so that for each consequences you have to take action, and prior to that you have to get a result. Okay, what is the result? You are going to turn off, you are going to turn on your heater, you're going to turn off your current, or you are going to stop your vehicle completely. If you have any damages, you will be stopping. All these things is, if you have a fire, what you are going to do. Main thing when you have using a lithium ion battery, when you get fire is disconnect all the power supply. Power supply disconnection is very, very important. So that cell destruction will be happening. If it is too late, you will have a cell destruction. Okay, cell may burst. So power, if you are disconnected everything, you can protect something. Okay, you can protect your machine, or if it is you can easily discharge, quickly discharge all the power. That is also important. Okay, if you can, if it is if it is in fire, if we can quickly discharge your battery with a cooler. Okay, if you can heat can be discharged with a cooler, it will be very helpful. The main problem with your lithium ion battery is if it is heated, there is a different research area you have. If your battery is in accident or any accident happened, how to isolate your lithium ion battery from any problem it is occurring, like a black box. If your accident occurs, your black box survives. Like that, they are planning to forward lithium ion battery. If you have to completely isolate your lithium ion, how to do it? Completely eliminate all the connections and completely safeguard it so that it will not burst and create another chaos. So how to do it? That is the main thing we have in research area. If any researcher are interested, you can do the research on that area. This is a prominent area in the electrical vehicle also. And you have what are the manufacturers you have in the market? You have Spike manufacturing and BMS. Only you can say that electrical vehicle means all the parts inside it is manufactured by one company. Each and every part in the electrical vehicle has been manufactured by different companies. Assembly will be done by another company. BMS will be manufactured by another company. All those things, and these are the companies listed out which will be manufacturing BMS. Okay, Spike, Ampere, Ion Energy, and you have Renesas Electronics, and then Green Go, and then Orion. All these companies have delivered their battery manufacturing with their key feature. What are the key features? They have your individual key features. I will leave it to your participant can uh, go through all those things. In every part, definitely you have to have a state of charge, state of health, state of your voltage, whatever it is, it has to be definitely present. Also, you have to have a temperature management also. These are the list you have for your different manufacturing companies which are providing in the market. Okay, coming for the how we are going to use your artificial intelligence in your battery management system is very, very important. That's our core of your today's session. We are using BMS. When we are going for your BMS, you have different control. You can see in this diagram how much control it is needed. All these control has to be managed by our some algorithm. So definitely, if you are going to create an algorithm for all these things, you want to have optimum value for each one, optimum temperature, optimum voltage, optimum cell balancing, optimum uh, voltage, current, temperature, all those things we have to maintain. Optimum discharge also we have to maintain. Optimum load, how much, if you are working at a particular load, your efficiency will be high. That thing you have to transfer it to a consumer. That is also important. All these things we can do it with your artificial intelligence. So artificial intelligence is a vast area. In that you have thousands of algorithms. I have presented only 6 algorithms as FI we have used for a long time. I have how to implement it. Yeah, him blinks of all the algorithms you have, and then you will go for a comparison of all those things. First thing we are going for a genetic algorithm. This genetic algorithm is generally an optimum method, optimization technique, where what you will do is you have set of values. That values you will be manipulating it and generating a different value which is better than the earlier value, as if we are generating a better uh, population than a earlier population. That's the genetic algorithm. You will have a next generation which is better than the previous generation through some process. Some process means you will be having a mutation process or crossover process. All these things will create a better next generation, so that you are going to a evolution and then reaching your destination faster and quicker. Okay, that technique has been adopted with the genetic algorithm. As if we are evolving, we are going to create a genetic algorithm. Genetic algorithm, even though not restricted to machine learning, it's a it can be a good help to a machine learning also. It can be used in state of health of an electrical and hybrid electrical vehicle application. See, lithium ion battery system, you can estimation of your modern parameters of lithium ion battery system can be utilized with a BA, genetic algorithm. And next is your bacterial foraging algorithm. In a bacterial foraging algorithm, what you will do is you have cluster of batteries, bacteria are present. Sorry, as we are speaking about the batteries repeatedly, batteries is frequently. Okay, bacteria, how your bacteria are behaving, that has been converted to bacterial foraging algorithm. What is foraging is, you are searching for the food. The bacteria are searching for the food and accumulating in the food point with moving, with a crawling. They will be moving towards the food area and then consuming it. Like that, you can mimic that bacteria, so that it will be searching for the global optimum. Okay, not a local optimum. You will be searching for a global optimum. You can see it in the figure. You have so much of bacteria present in the search area. They will be converging to a global optimum point. Okay, after processing, they'll be converging to a global optimum point, so that you will get a good result. If you are operating the vehicle or selling a particular voltage or temperature, you will get optimum results. That's a way it is doing. Okay, you will have a mean fitness charging level, how many iterations it will take to converge to a global optimum value. All those things we have to take over. You can apply these techniques at any part, but in case of a lithium ion batteries, you can use this bacterial foraging technique for estimating unknown parameters. Unknown parameters, if you are knowing, is not known for unknown parameters, it is very useful to find the unknown parameters. And next is your partial swarm optimization. You usually call it as PSO. Okay. How it is designed is, it is based on the behavior of the birds and flies and how they are converging to a particular point without um, any any direction. If one bird can fly in another way, but everything is going to synchronize it as itself and going to fly it in a particular way. Okay, that is the synchronization they are having. So following that, how we are going to do it with your particle swarm optimization. In this case, you can see particles will be present at initial state and it will be moving direct in different ways. But what it takes, even though it starts moving in a different way, it will at last synchronize with the other particles, which is best. Okay, which is best, and then follow that best path, and then synchronize with all the best path. Okay, all may be traveling at any direction, but what is reaching, getting a better fitness or better fitness value, other things starts following that fitness value and then start flowing in that path and then get a better function. That is the partial swarm optimization. That is a very interesting topic. You can also use that topic for optimization. You can use genetic algorithm as well as partial swarm optimization for optimization. These two are optimization techniques. Battle foraging can be utilized for algorithms also, not even for optimization. You can use other also. In coming for a fuzzy logic, it's my favorite topic as I did my PhD in fuzzy logic technique. You can see fuzzy logic. What is a fuzzy logic? In real time, you can see, you can say true or false. You cannot say. Sometimes it may be between that. That's a fuzzy logic case. You cannot say yes. You cannot say no. Both it will be between. That's a gray area. There will be gray area where you cannot say yes or no. Okay. Both in between that will be a fuzzy area. That's a gray area will be converted as a fuzzy. Okay, that gray area design decision will be taken by the humans. How we are going to take a decision on the gray area? That's the important part of a fuzzy logic. What you will do is you will not decide with crisp value. Okay, you will not if you are saying that 6 feet is tall, 5.9 is short. Okay, 6 feet and 5.8 is similar. You cannot say it is short. So we cannot define it with a line. Okay, so that is a gray area you have. And that gray area can be converted to a fuzzification. And that you have a gray area with a triangular merge function. All these things you have. First thing, what we will do is we will convert into a crisp value into a fuzzification value. Always you will be converting into terms which will understand more. That 6.1, 6.2, you cannot understand. You even if you understand the number only, you can understand. Then we can convert that into taller, shorter, like that. That's a falsifier value function. After falsification, you will be applying your knowledge. What is the knowledge you have? What will be the decision with your experiment? That will be stored in the rules. Okay, now your knowledge, how you are going to implement it in the real time will be stored as your rules. That can be, you can use your simple if then rule for sorting it out. You can store these rules in the intelligence. With that intelligence, it will use that intelligence from the input to convert into a specifier, and then as machine does really understands only a crisp value, it will give that crisp value as an output, and that output will be utilized for any solution. Okay, what's the main problem with your fuzzy logic is it needs more storage and time consuming. It is very, very time consuming in case of the fuzzy logic. One second. Say next is here neural network. In a neural network, As Somasundan sir has already given a brief introduction on neural network. And neural network, you have different layers in the neural network. You have 2 to 3, 3 to 4, or numerous layers in your neural network. For example, I have given an example. You have an image. You will be taking a feature of your image by 256 into 256, then compress that into a smaller image of 128, and then again classify that into a different section, and then again simplify that into a 64 into 64, and then create out. This is how our neural networks will be implementing. We can see the feature mapping. You can how we are 256 into 256 data. Only featured values will be selected, and then that is reduced to a number. And then next part it is again subdivided into its required part, and then again reduced. Okay, this is how they are using a techniques to obtain an optimum value. Okay. Okay, and then you will have a fully connected outputs. Okay, you have sub sampling layers, conventional layers, subsampling layers. Also, you can have any number of layers until you get an optimum value. Then you will get keeps on adding up layers. Okay, that's the important thing. It is completely on how we are going to mimic your neural network. Okay, mimic your neurons. Mimicking neurons is a very good technique. That is a promising technique that you can use it to any part. Okay, uh, probably the back propagation technique is very important. That is giving us a best result as it is having a feedback. This feedback is correcting our input. Okay, this feedback from your output is keeps on correcting your outputs. Based on your input, your outputs has been frequently connected, and then we have learnings also in the neural network. We can learn, but what is the main drawback of this neural network is it should have a numerous kinds of training. Training, if you want to store at least 100 data, it will go for 10,000 at least training types. Okay, 100 into how many parameters, that much time you want to go for training. Training is very important. Not once, it will take hundreds of iterations also. Okay, training is very long process in your neural network. As if you are training a cycle in for a child, it has to take a long process of neural network. And you have adaptive neural network also, in which case you can use a fuzzy logic as well as neural network combined together to get. Okay, in this case you can have a fuzzy logic, triangular or a sinusoidal, trapezoidal inputs, and then combine it, use that logic, if then logic in the neural network, and then implement in the network, so that you will get an optimum result is the ANFIS. Okay, this is also have been proven technique that also we can use it for your algorithms. And next is a support vector mechanism. In this case, we'll be using a vector line. Okay, you can see the vector lines which is dividing your uh, positive things and negative things. You can see blue dots are positive, it is creating a result of positive, and red dots are creating another layer. You can use it for classification also. These structures, support vector mechanism, you can use it for over voltage and under voltage. If you can classify which are all over voltage, which are all under voltage. So we can use it for classifying complex values, which is keeping on changing. Okay, uh, what is very classical in this is you can respond to a changes in linear model from non-linear model also. That is very classical in your support vector mechanism. Next is multi-variable adaptive regressive space. Okay, in this it is shortly called as MAS. You can see the MATLAB diagram with which it is implemented. It is actually introduced in 1991. You have numeral data. It is a type of neural network only. Okay, but you have multivariable. Regression is you have multiple feedbacks. When you have regressive, it is completely a feedback network. What is beneficiary with this is it can be implemented in microcontroller also, low cost microcontroller. Usually you cannot implement other techniques without FPGA. Okay, you will be having a costly controls. That's the main drawback, but this method can be implemented with low cost microcontrollers. That's a beneficiary methods. Okay, and next is recurring network. Current neural network, you can see the feedback from the layer 3 to layer 1. You can have a feedback so that your process has been correcting itself. Okay, a forward feedback network is very, very important so that whenever you get recurring, it's a feedback network. Okay, feedback network is very important to correct itself. That's the main thing. You can do it with your recurring neural network. Okay, recurring neural network or whatever it is, you have feedback. It is simple network. Yeah, this simple network can be used very simply as it depends upon the previous state. Okay, it is very, very important for a cell to maintain previous state. What's your previous state? I am going to charge. If it is fully charged, if it is again going to charge, what happens? It should not be, it takes a note of your previous state. Previous state is very important for what is the condition I am going to do next. If I am battery low, I'm going to charge again. If I am already charging, next state, if I am not reaching the average value, again I am going to charge it. So that's the previous state I want to know. If I am reached the limit of which I have normal voltage, I'm going to stop the charging. That's the previous state advantage. That advantage you have recurring neural network. Most of the experts will be using recurring neural network only for your implementation of projects. It's very, very simple as well as it is giving you high accuracy also. It is very simple to design also. That's what always you will go for recurrent neural. And you have a summary of all these AI techniques. What is the advantage of advantages, limitation, or application, whether you can use it or not. See, genetic algorithm, it is robust to noisy environment. Okay, and you can have a high accuracy in case of genetic. But what is the problem with this? It is time consuming. If you want so many iterations and search all the space in the region to converge to a point. So more computation time it will take. So is it applicable for e-mobility? Yes, definitely it is applicable to e-mobility. And coming for a bacterial foraging, it gives moderate accurately only, and then it have high latency. Latency is iteration, number of iterations will be using. Why it is not suitable is bacterial foraging. Now, until now, it is not used. Only genetic algorithm has been utilized as bacterial foraging. It is not used because foraging takes time, right? So that only it is not utilized Dell. But genetic algorithm is most popular than bacterial foraging, it is utilized. That's all. You can also use, but how much beneficial if you are going for GA and FPA means I will definitely go for GA. Okay. Then coming for PSO, modern and is moderately accurate. Okay, and it's also high latency, but you can use it for your e-mobility. And coming for fuzzy logic, moderately accurate in different conditions. Different conditions uh, is the point which you cannot apply for others. Okay, different condition you can utilize for fuzzy logic, and it requires large data storage is the main disadvantage of your fuzzy logic. And it is needed expensive data processing. I can say that if it is using FPGA, all these things, it is very important it is becoming costlier then. And next is here you have seen neural network. In that case, you have mass and then RNN, recurring neural network. All these things will be moderately accurate only, and it requires large data storage, and the number of experiments are needed to be validated. And uh, a recurrent neural network needs a large space and depends upon the training on NNN. Okay, all these things can be used, but mass we have not used for your practical vehicle. That's a point because it is very complex. That much complexity is not needed for your e-vehicle. Okay, that's what it is not used. If it is very complex, then you can use it. And that's all. Why you are going for this motivation for your research is you are going to have a 7.6 billions by 2021 for artificial intelligence and machine learning. Okay, it's a report from International Data Corporation. It is telling that by 2021 they will be spending 57.6. And another company is telling that you will be investing $105.8 billion by 2025. So there is more scope. As you have more scope in your artificial intelligence technique to control your other, not only e-vehicle, but also other techniques, you can have so much scope on research also. Thank you. If you have any questionnaires, you can ask. Thank you. Thank you so much for patient listening. And these are my references. You can, I have loaded my PPT in the Teams itself. If you are gone for 5, you can see that. Thank you. If you have any question, you can ask. You have any questions?
Good afternoon, madam. Your knowledge sharing is good. I have one question regarding this multivariate adaptive regression. You told it can be implemented in microcontrollers as well. What you mean is the processing power required for this is less. Is that so?
Yes, sir. The processor, it can be, the structure is complex, sir, but when you can implement it in microcontroller also, sir. I will go for my presentation.
Yeah.
Once again, came out of that. Yes, sir. The mass can be utilized in microcontroller definitely, sir.
Okay.
Because the size of the algorithm is very less. So we can that is not needed much of the size. That's what. But it needs it can process many functions.
Okay. Okay, madam. Yes,
Thank you.
thank you.
Any other questions? Okay, then we can close the session. Thank you, participants. Mosi?
Thank you, madam. Thank you.
Thank you, ma'am, for sharing your expertise in the field of artificial intelligence in battery management system. And we are delighted to have a glimpse of topic from you. We could like to inform that the next section will start around 3 p.m. Thank you all.